Hello and welcome back to our video walkthrough of exam style questions for the 2020 NCEA Level 2 Calculus exam. We are now on question 2. If you missed the question 1 video, there will be a link somewhere on the screen to go and view that. So question 2, question A. The graph of a function f of x is shown below. So we can see we've got a negative cubic there. So remember, negative cubics always go like that, so down, up, down. Sketch the graph of the gradient function f dash of x on the axes below. Both sets of axes have the same horizontal scale. They've just told us that so we can make sure that we line them up. So we've been given f of x and we need to draw f dash of x. So first of all, we want to think about what we've got, which is a negative cubic equation. So if we differentiate that, which is we're differentiating because we've got f of x, we want to get f dash of x, then the derivative is going to be a negative quadratic. A negative quadratic will look like that, an upside down parabola. So the key thing here is that when f dash of x equals 0, so the gradient is 0, that is a turning point on f of x. So we want to find those turning points, so we can see we have got one here and one here. It's a cubic equation, so cubics will typically have two turning points. So what we're going to do is just line these up like that. Okay, so we know that we're going to have an upside down parabola. Now it's a question of what's it going to look like? Where does it go? So remember, f dash of x equals 0 at a turning point. So the gradient is 0 at a turning point. So if we look at this graph, f dash of x will be 0 if we're on the x-axis. So just like on a normal graph, if you're on the x-axis, y or f of x equals 0, it's the same here. So f dash of x will be 0 here and here. So these are the x-intercepts of our parabola. Parabolas are symmetrical, so the turning point should be halfway in between these 2 points. So we'll just count 1, 2, 3, 4. There are 4 parts. If we go 2, it's in the middle. Now, it's a negative parabola, so the turning point has to be above these points. Doesn't matter where we put it, so long as it is above them. So I'll put mine here, but again, it could have been here or here or here or here. That would have been absolutely fine. Just has to be above the x-axis, and then sketch a negative parabola through those points. And just do your best. And there we go. That is that question answered. So if you get intercepts in the correct point, so again, x-intercepts of f dash of x line up with the turning points of f of x, and it's the correct shape, so in this case a negative parabola, then that is all you need, and that is an achieved question. Okay, on to B. Find the x-coordinate of the minimum point on the curve y equals x cubed minus 8x squared plus 5x plus 3. Explain how you know this is the minimum point and not the maximum point. So we've been asked to find the x-coordinate, don't need the y-coordinate, just the x-coordinate. So find the x-coordinate of the minimum point on this curve. And then we need to explain how we know it's the minimum and not the maximum. Okay, so minimums and maximums are both examples of turning points. So if we think about this graph that we've got, that is a positive cubic equation, so the graph will look something like that. Now, as you can see, that has got 2 turning points, just like the cubic from the previous question. So on a positive cubic, it will always go like this. It will always go up, to its local maximum, then down to the local minimum, and then it will increase again. So if we're being asked to find the minimum point, we need to find that second turning point. So remember from before, we said that turning points happen where f dash of x equals 0, whether it's a minimum or a maximum. So we first of all need to differentiate and then solve for when f dash of x equals 0. So again, anything to do with gradients, always a differentiation question. Okay, so let's differentiate. So dy over dx equals 3x squared minus 16x plus 5. So we know that dy over dx, or f dash of x, is 0. Now, got three options here. We could try and factorize that, or we could use the quadratic formula, or the easiest way is to use your graphics calculator. So you go to the equation function and then polynomial degree 2, because this is a quadratic, and we'll just go 3, then negative 16, then 5, and solve, and we get two answers. We get x equals 0.333, or 1/3, and we get x equals 5. So we know where the turning points are. We don't know at the moment which one is which. We just know where they are. So if we look at my little sketch in the corner there, we know that the local maximum will come first if we're looking left to right. So that will be at the lower x value, which would be 1/3 in our case. And the local minimum will be at the higher x value, which is x equals 5. But we need to prove it. Now you can sort of just explain that, but the best way to do these questions is to double differentiate. Use the second derivative to prove which one is the local minimum. I like having the sketch though, so that you can verify the answer is correct. So we will differentiate this one. D squared over dx squared. So second derivative is 6x minus 16. And then what we're going to do is substitute the x coordinates into this second derivative, and we'll see what we get. So going back to the regular calculator function. So when x equals 0.33, so 6 times 0.333 minus 16 is negative 14. And then when it's 5, it is positive 14. The exact number you get doesn't matter. All that we really care about is whether it's positive or negative. So the rule is when the second derivative gives you an answer that's less than 0, so i.e. negative, then that tells you it is a maximum point, local maximum. If you get a positive value, then it is a minimum. So that is the best way to mathematically prove that that is a local minimum. So the question was find the x coordinate of the minimum point. So the minimum, therefore the minimum is at x equals 5. So to get achieved on this question, you have set the derivative to, you've differentiated and set that to equal 0. So getting there is an achieved, and getting the full answer is a merit. The other way that you could prove that is to calculate the y coordinates of the points. So of course the local maximum is higher, so you'd get a higher y value than for the local minimum. any of those are best. Again, personally, I prefer the second derivative. Okay, on to question C. The speed of an object is given by Vt equals 4t squared minus 17 meters per second, where t is measured in seconds. What is the object's acceleration when t equals 5? So like I did for the kinematics question in question 1, I like to draw myself this dV8. So again, we differentiate going down and integrate going up. Helps me visualize what we need to do. So we have been given the velocity or speed, and we want to know about its acceleration. So we need to go downwards. So that means we need to differentiate. So AT will equal 8t minus 7. And we've been told t equals 5. So substitute 5 into that equation. Well, 8 times 5 is 40. Take away 7 is 33 meters per second squared. And there we go. That is it. That is the answer. And that is, as you probably guessed from the quick working out, that is an achieved question. Okay, on to question D. The graph of a gradient function is shown below. The point A0 is on this graph. So there is that point, A0. So A being the x-coordinate, 0 is the y-coordinate. No, it's a y-coordinate 0 because it's sitting on the x-axis. Sketch the graph of the function y equals f of x below, given that f of a equals 0. So what we've been told is that that point, A0, is on f of x, as well as the gradient function. So what we're doing the reverse of what we did in this previous question here, where we were given f of x, we had to draw f dash of x. This is the other way around. We've been given f dash of x, or dy of dx, and we need to draw f of x. So remember that this graph, the gradient function, is showing us the gradient of f of x at different x values. So here, at a and 0, and also here, f dash of x equals 0, or dy over dx equals 0 at these 2 points, which means that the gradient of f dash of x is 0 at those 2 points, which means those must be turning points. So we need to line up our turning points with these x-intercepts of f dash of x. So I'm going to do these lines of the way problem because we don't know where they're going to be yet. Now, we can figure that out though. Again, it's nice to do a sketch first so we can visualize what's going to happen. So this is a negative parabola, our gradient function. So if you integrate that, it's going to be a negative cubic, which will look something like this. So the first turning point will be a local minimum, and the second one will be the local maximum. Now what we know is, though, that this cubic, f of x, is also going to go through A. But it's also a turning point. So this point here must be a turning point for it to go there. So it means that the turning point is actually sitting on the x-axis. Okay, so that's all the information we need, really. We can draw that turning point. Now, because, again, that is the local minimum, the other one, further to the right, must be the local maximum. So I've got to put that above. Now, we don't have too much room, so we'll go nice and high with that. Okay, so let's draw it. So we're going to go down to this local minimum, then up to the local maximum, and then down. And that is our graph of f of x, our negative cubic. So these ones are merit questions to start with f dash of x and draw f of x. So you'd get achieved if you got the right kind of shape. So if you drew a negative cubic, that would be enough for achieved. The turning points have to be in the correct place, so lined up with the intercepts of f dash of x or ty of dx to get the merit. Okay, on to the last question for question 2, and you might expect this is the excellence question. A cubic function f of x equals ax cubed plus bx squared plus cx plus d has turning points at x equals -2 and x equals 4. Find an expression for c in terms of a. So they've given us just a whole load of letters here instead of actual numbers. But we have been told crucially where the turning points are, and we want to find an expression for c in terms of a. So what that means is we want to end up with an expression or an equation that says something like c equals something something a something something something. It needs to look like that. So you might be thinking, well, how on earth are we going to do that from what we've got? But again, it's all about those turning points. And again, this is a calculus exam, so you know this question is going to either require differentiation or integration. Now, because we're talking turning points, differentiation, because that is related to gradients. Because remember, at turning points, gradient is 0. Okay, so let's differentiate. So f dash of x equals 3a x squared plus 2bx plus c. So notice that nothing really happened with the a's, b's, and c's. We're differentiating with respect to x. So the a, b, and c stay the same. Remember, they are just numbers that we don't know. So you might be thinking, well, how has that helped? Again, we know the turning points. We know where they happen. And again, that is f dash of x equals 0. So there's two different possibilities for how to get 0. So we get 0 if we put -2 into this equation. And also when we put 4 into this equation. So anytime cx, I'm going to put -2 into that one. Before we do the other one, we'll just work this out and simplify as much as we can. So -2 squared is 4, times 3 is 12, so that will be 12a minus 4b plus c. Okay, and for the other one, when x equals 4, so I'm going to do the same thing, just substitute 4 in instead. And again, just work it out. So 4 squared is 16, times 3 is 48, plus 8b plus c. Okay. So we have got two equations there that have a's, b's, and c's. So again, just to recap, got those by substituting in these x coordinates that we were told, -2 and 4, because we know that is where turning points happen, which is why we've made f dash of x equal 0 in both of those. So the next thing, remember, our objective is to write an expression for c in terms of a. So what we're going to need to do is to rewrite this, and it makes no mention of b, so if we can eliminate b, that would be great. So we're going to do some simultaneous equations here. So what I'm going to do is I'm going to times this first one by 2. So I've got to times everything by 2. Every term in that equation is going to get multiplied by 2. Well, 0 times 2 is still 0. So that equals 24a minus 8b plus 2c. So because I've multiplied everything in that equation, it's fine. It's not actually changing the values. Everything will still work out just fine. So the reason I've done that is that gives me -8b compared to that positive 8b. So now that we've got -8b in here, that's good. We can, if I add these together, I can eliminate b. So we'll go 0 equals, not 24 because we're adding, it's going to be 72a. 8b take away 8b is 0, that cancels out, and then c plus 2c is 3c. So if we just remind ourselves of the question, find an expression for c in terms of a. So we need to rearrange this and solve for c. So we'll take away 72a from both sides, and then divide both sides by 3. So if we just double check, 72 divided by 3 is 24, so it's going to be negative 24. So c equals negative 24a. And there is our answer. We have got an answer for c in terms of a. So in terms of the grading for that question, for achieved, correct expression for f dash of x involving a, b, and c. So getting to here would be an achieved. For merit, forming the two equations using the information about the turning points. So that would be all of this getting to down here. And then for excellence, you have got the answer. And there we go. That is question 2 complete.